It's me Chandralama. Today I am going to discuss 3 questions. First one is, give an example of the relation on the set of positive integers which is symmetric and reflexive but not transitive, reflexive and transitive but not symmetric, neither symmetric nor antisymmetric. Okay, let us suppose A is equal to 1, 2, 3, then number I. Consider R1 is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 3, 3, 2 is reflexive and symmetric, but it is not transitive. Since 1, 2 belongs to R1 and 2, 3 belongs to R1. As we can see, 1, 2 belongs to R1 and 2, 3 belongs to R1. But 1, 3 does not belongs to R1. So it is not symmetric. Next, number II. Let us consider relation R2 is equal to 1, 1, 2, 2, 3, 3, 1, 3, which is reflexive since there exists 1, 1, 2, 2 and 3, 3, and transitive since there exists 1, 1 and 1, 3. So there exists transitive 1, 3 but not symmetric. Since 1, 3 belongs to 1, 3 belongs to R2 but 3, 1 does not belongs to R2. Next, solution for number 3. We have to prove neither symmetric. We have to give an example neither symmetric nor anti-symmetric. Let us consider R3 is equal to 1, 2, 2, 3, 3, 2, which is neither symmetric since 1, 2 belongs to R3 but 2, 1 does not belongs to R3, and also nor anti-symmetric since 2, 3 belongs to R3 and 3, 2 belongs to R3 with 2 not equal to 3. So it is not anti-symmetric. Okay. Next I am going to discuss the question. Prove that for all sets A and B, A intersection B whole complement is equal to A complement union B complement. The solution is like this. Let us consider A and B are two sets. Then 1, 2 belongs to R1 and 2, 3 belongs to R1. But 1, 2 does not belongs to R1. So it is not anti-symmetric. Next, Then we can write A intersection B whole complement is equal to double implies X such that X does not belong to A intersection B, since by the definition of complement, and it double implies means A intersection B whole complement implies to this one, and this one implies to, and A intersection B whole complement, vice versa. And we can also write this like this: X such that X does not belongs to A, or X does not belongs to B. We can write it logically, and from the definition of complement we can also write X belongs to A complement. X does not belongs to A means X belongs to A complement, or X belongs to B complement, and which double implies X belongs to A complement, or X belongs to B complement. That means X belongs to A complement union B complement. That means A complement union B complement. And here we can write this, since by the definition of union. So therefore A intersection B whole complement is equal to A complement union B complement. Hence proved. Okay, next I'm going to discuss about the question. Show that the relation R in the set of integers is given by R is equal to A comma B such that A minus B is divisible by 2 is equivalence. And next question is, consider the following relation on 1, 2, 3, 4, 5, 6 the set, and then R is equal to I comma J such that mod of I minus A is equal to 2 is R reflexive, or is R symmetric, as is R transitive. For the question number A, we have to show that R is equal to A comma B such that A minus B is divisible by 2 is equivalence. So for this, let A belongs to Z integer, then we can also write that A minus A is equal to 0, and 0 is divisible by 2. Therefore we can write that A relation A for all A belongs to Z. Hence R is reflexive. And again you can also write that A relation B, which implies A minus B is divisible by 2, which is given in the question here like this, which implies minus A minus B is divisible by 2, and we can also write like this: B minus A is also divisible by 2. So we can write like this: B relation A. Hence R is symmetric. A relation B is implies B relation A, so it is symmetric. Next, consider A relation B and B relation C, which implies A minus B is divisible by 2 and also B minus C is divisible by 2, which is given in the question, which implies A minus B plus B minus C is divisible by 2. That means A minus C is divisible by 2, which implies A relation C. Hence, A relation B and B relation C implies A relation C means R is transitive. Since R is reflexive, symmetric and transitive, therefore R is equivalence relation. Question we have to find out whether R is reflexive or R is symmetric or R is transitive if R is equal to I comma j such that mod of I minus j is equal to 2. For this, let A is equal to 1, 2, 3, 4, 5, 6. Let us consider a set. Then R is equal to I comma j such that mod of I minus j is equal to 2 on A, which is given in the question. That means we can form a set relation 1 comma 3, which is mod of I minus j is equal to 2, 1 comma 3, 2 comma 4, 3 comma 1, or it may be 4 comma 2, 3 comma 5, 5 comma 3, 4 comma 6, or 6 comma 4. Here R is not reflexive. R is not reflexive since there is no I comma I does not belongs to R. For all I belongs to A. Here we can write R is symmetric since for all I comma j belongs to R, there exists j comma I also belongs to R, but R is not transitive. R is not transitive since for all I comma j and j comma k belongs to R, but I comma k does not belongs to R. For example, 2 comma 4 and 4 comma 2 belongs to R. Here we can see 2 comma 4 and 4 comma 2 belongs to R, but 2 comma 2 does not belongs to R. That means hence R is not